Alright, hello everybody. This is 6.5. We're going to look at properties of logarithms. And these are the 7 big ones, and we have to have these memorized. So logarithm, first property. Log any base a, if you input into a 1 to a logarithm, you get out the number 0. Okay, log base a of a equals 1. And then these two are your composition. This is from the composition of inverses. So a raised to the power of log base a of x equals x. You can think about these guys undoing each other. They're going to cancel out. It's got to be the same base. So a raised to the power of log base a. And same here. Here's composition the other way. You have log base a, and you're inputting in an exponential of the same base. These guys are going to cancel out, and you're going to get x. So that's your composition of those two. And these three are very, very important. Here you have log base a, and what's important here is you have multiplication of inputs. That turns into addition of logs, and the base stays the same, a. And here division, and division of is in the inputs. It's not log base a of m divided by log base a of n. It's log base a of m divided by n. So the input here is where the division is, just like the input here is where the multiplication is. So it's not just any time you see multiplication. It's got to be in the input of, or for division it has to be in the input. And the last one, again, here the input has the exponent. You can bring that out front via multiplication. So let's take a look at how we can use these. Okay, so I want to write the following as the sum or difference of logs and express all powers as factors. And here I have one logarithm. So here in this input I see division, so I can turn that into subtractions of the logs. So I have ln of all this stuff, and here's where the division is. So I can rewrite this as ln x cubed minus ln x minus 1 to the 4th. And then finally I can bring powers out front. So this is 3 ln x minus 4 ln x minus 1. A couple things to notice. First of all, the base stays the same here. It didn't turn into a different logarithm. And you cannot combine these two things. They are unlike terms. They have the same logarithm, but they have different inputs. So here, be careful. You're done at this step. You can't put them together. So take a look at one more. Let's say I have log base 7 of x squared times the square root of x cubed plus 1. So here you have multiplications, that turns into addition. So I have log base 7 of x squared plus log base 7 of square root of x cubed plus 1. And then let's see what else we can do here. I can bring this 2 out front. So this is 2 log base 7 of x plus, and then here I can rewrite this as log base 7 of x cubed plus 1 to the 1/2. And then finally I can bring that power up front. So equals 2 log base 7 of x plus 1/2 log base 7 of x cubed plus 1. And then that guy is done as well. And again, these are unlike terms. You can't put them together. They would need to have the same inputs for you to combine them, and then you would add coefficients appropriately. And this stays log base 7 throughout the whole problem. It doesn't change at all. Okay, let's try the other direction. Okay, we're going to try to write the following as a single logarithm. So first of all, they're all the same base, and that is super convenient. So I don't have to do any kind of change of base thing. And here you're going to work in the opposite order of the previous problem. So the last thing we did was bring exponents down. So the first thing here is any coefficients you're going to bring up as exponents. So this guy's fine. It doesn't have any, has a leading coefficient of 1, which is perfectly okay. Same with this guy. But here the first thing I'm going to do is I'm going to move that 3 up. So minus sign stays minus, so ln parentheses x plus 1 cubed. Okay, and now here I have addition of two same base logarithms. That turns into multiplication of the inputs. And finally I have subtraction of two same base logarithms. So final answer here is ln x squared plus 1 over x plus 1 quantity cubed. A lot of times they want you to leave it in this factored form. But if you could cancel out something in here, if you could look at this like a rational thing inside, you could simplify it, you should. So for example, if this was just x plus 1 up here, I would cancel out with that with one of these powers in the bottom. But here I'm done. I followed the directions. I've rewritten this as a single logarithm. And it's got the same base. Didn't change base at all. Okay, let's take a look at one more property. Okay, this is called the change of base formula. So here, say you have some base that you don't like working in. It's not one of the ones in the calculator. You can change it to any base you want with this formula. So here, A is the old base, and M is the input. You can put it into whatever base you want, but it has to be the same. So ln, or the common base, or something like that. The input of the old logarithm is the input up top. So I think about it, this guy goes up here, and the old base turns into the input on the bottom of the new base. So for example, let's say we want to approximate log base 7 of 3. So here we're going to do that change of base formula. So I have log base 7 of 3. And I'm going to use ln because I know where that button is in the calculator, but the common base for base 10 you could use as well. So I'm going to put this into log base e, so ln, and here the 3 is the input upstairs, over ln, and 7 is the input in the bottom. And this you can put in the calculator, and I get 0.56 rounded to 2 places. Okay, that'll do it for this video. Good luck.